this is Andreev. You probably know this guy, and you're probably not sure who I am.
Why did you choose Lego, by the way?
Lego, because it's building.
We're builders, right?
Yeah, we are builders. I have it in a t-shirt. It's time to build on Ton.
These guys invented their own type description language. They have their own, data storage format. They have a lot of concepts that are just, made for this project. We decided to build a wallet for the network, and I had to take a second look. And this again was, over my head, but now I had to actually crawl through all this content.
Doesn't mean that people were the biggest source of truth for you in understanding Ton.
What do you do, man? It's the wrong piece. Where? We need to use the plank.
Oh. Hi guys, my name is Mark, and this is Andreev. You probably know this guy, and you're probably not sure who I am, but I'm super happy to tell you that we are right now together in Dubai, because we actually got together to shoot a course on programming in Ton. And it was not just fancy, it was a lot of very basic conceptual stuff that Oleg did an amazing job on actually breaking it down, getting ready for actually showing the building blocks of what Ton consists of, and what are the decisions that made in Ton and why they're so cool and important. So we decided to actually spend some more time in the chill atmosphere with Oleg to talk a little bit more about why do we even do the course like that? What are the underlying problems that developers are facing when they actually come to Ton? Why so much of them leave before even understanding some concepts? And one thing which we'll do also is we'll try to limit our conversation by the time that we will actually be able to construct an office. We'll choose the simplest version. So let's see how it goes. It was a long time since I actually used Lego.
Well, hi Mark. Hey everyone. We'll start.
Yeah. So I will at the beginning just open the back, so we could actually send our sample centers, get a visit.
Why did you choose Lego, by the way?
Lego, because it's building.
We're builders, right?
Yeah, we are builders. I have it in a t-shirt. It's time to build on Ton. It's not Lego though. Yeah. Yeah. So when you first heard of Ton, or you actually started to get involved with Ton, was it like you read the white paper and you got it, or what was your path, like in short?
Well, the first time I saw the white paper, I think it was like a leaked white paper, or I don't know, when the thing was ready to
ICO times.
Yeah, to go on ICO or something like that. And that was just way over my head, because I was designing my own blockchain, format, and my white paper was 8 pages long, and this white paper was, 4 volumes of over 100 pages long each. And so I kind of skimmed through this and like, okay, these guys invented their own type description language. They have their own, data storage format. They have a lot of concepts that are just, made for this project, and this was just way over my head. So I kind of like scrolled through this and was not even sure that it's authentic, and basically forgot about it. And then the second time when I learned about Ton is slightly over a year ago, when I learned from my friends that the thing actually exists after all the, drama. And we decided to build a wallet for the network, and I had to take a second look, and this again was, over my head, but now I had to actually crawl through all this content, and this was not easy. And I'm like very grateful to all the knowledgeable people in the community and in Ton Foundation who were like very eager to help and explain, in simple terms how things work and why things are designed this way. That's the the biggest thing in the design of for any complex system is understanding the rationale behind the design decisions.
But doesn't mean that people were the biggest source of truth for you in understanding Ton.
Yeah, I would say so. Yeah, like just hands-on understanding by other people who could explain in simple terms certain things from different angles was crucial. And this is why I'm spending a lot of time, trying to explain Ton to other people from, what I learned
Man, I appreciate it so much. Honestly, it's hard to get some people to even spend like 10, 15 minutes talk, get the questions, and you're spending so much time with us.
Do you have a small gray thing like this one? I couldn't find it. This one? I have this one.
Oh, no, I didn't see that for, but that's actually that's an interesting point. Like when I build something, same for programming, I try to actually organize what we got. So it's for me, it's the best to actually when I meet some concept later on. Like this is why I was so confused with cells actually.
Yeah.
But then cells is such a like hands-on thing that you have to understand from the day one. But it took me like weeks of just looking into other people's code and asking stupid questions to just understand it. And I was shocked when you just read it today in white paper. I didn't read white paper for a long time.
Yeah,
It just sounded so clear for me. It was like great.
you know, only after a year or maybe like half a year working in this environment, I started to understand how to read the white papers, you know, slowly and carefully. Now you kind of know like why certain things exist, and then your brain doesn't, you know, block out some complexity. You just like kind of read carefully and understand how things, you know, put together.
I think
Oh, these are the black.
this is black. I think they're just not supposed to be gray. They're the kind of black.
Yep.
Yeah, they actually. This is the basement connector. Yeah.
Yep. All right.
Okay. So you're taking the basement.
Let's go to the next page.
Yeah. So you get all the black.
So what do you want to know about cells after all?
I will tell you one thing that I found very helpful, but you might say I'm wrong on that. But so the term that really helped me to understand cells is that it is a memory layout. So no one called it memory layout before. I actually like some guy just said this term. So it's memory layout. So I have like my whole memory is just laid out into cell.
Your whole memory flashed in front of your eyes.
Yeah, kind of. Yeah, but it's right now I don't have questions about cells, but there are certain things, not just cells. There's more things that I was very shocked how simple they are, but no one explains them in a simple way. So, for example, this deterministic addresses, it was such a concept. Like I figured it out like coincidentally. So some guy just said like, okay, just calculate the address. I was like, what do you mean, calculate the address? Don't I have to deploy it and then know the address? And there is a number of simple patterns like this, but people don't actually go around and they don't explain it like that simple way.
Okay.
Like, do you see that problem in Ton or not? That
Yeah, I mean, there's definitely like a lack of thorough documentation compared to the amount of things that exist. So for instance, like back to the cells, the first question is like, why do we even have cells? So in a thing like Ethereum, you have this programming model that is quite familiar to people. You just write a program, allocate the memory, like in bytes, you know, just how many bytes you need, you just take them. There is some, you know, costs in terms of gas and fees to, you need the gray one. I think there's just one like that. And you can program like you would do in a computer, right? Here it is. And this is familiar model. And in Ton, they say you cannot just allocate the memory. You have to, you know, work with those cells. And you're like, okay, why do
you have to manually allocate for everything?
Yeah, you have to fit your data in this 1023 bits, and then if they don't fit, you put it in the, you know, children cells, and you build this tree of cells, and this is and this has, you know, non-trivial costs, because every time you have to jump into inner cell, it's higher cost in terms of fees, and you're like, what is going on? Like, why is this so complicated? So the simple answer is that the Ton is designed all around the wow, these are weird pieces.
Yeah. I didn't see them before.
Yeah, look, I didn't see those in my childhood.
Yeah.
All right.
Well, it still acts the same if you step on it. It's no different from different work.
All right. So, oh yeah, there are those.
What are windows?
Um,
and I'll keep building with this green node.
Yeah, so Ton is really built around the idea of, you know, infinite scalability, and one of the necessary components of this infinite scalability is a need to prove some parts of the state of the system in a compact way, meaning that something happened in some smart contract or in some validation of some transaction somewhere. If this event was correct and you need to prove that something happened, or it was incorrect and you need to prove that it was correctly done, you need the proof. And effectively you need to provide some pieces of data that are inconsistent and cryptographic proof that chains them down to some commitment up on the top of the blockchain, somewhere to the block or to the state of the blockchain. And the tool that is often used for this is called Merkle proof.
Merkle proof.
Yeah, like Merkle tree is this kind of abstract data structure where you have the tree of hashes, and the Merkle proof is this branch from the root down to the element. And the big idea in Ton is that everything, the whole state of the blockchain, all the blocks, all the state, everything, is uniformly represented in cells so that any piece of the blockchain can be kind of Merkelized, can be proven with this compact proof. And if everything is packed in cells, it means that at no point in the system you have some giant allocation of data that takes a megabyte or a gigabyte. You always have those compact cells, so you're guaranteed that the cost of your Merkle proof is always like logarithmic in the size of the data structure, which is pretty low, multiplied by the small number of bits. Right? And so they just uniformly said, hey, let's just build the entire blockchain out of those cells so you can Merkleize anything anywhere, and then just move on. Oh, by the way,
I found it.
No, it's not symmetric. It should be symmetric. It should be symmetric. Watch out. Yeah.
So basically, we have cells because it's easier to maintain the proof of state change on the blockchain with this kind of structure with this Merkle proof. And like memory type is just like cell type of memory is just makes it easier, right?
What are you doing, man? It's the wrong piece. Where? We need to use the plank.
Oh.
Yeah.
Okay.
Yeah.
So, all right. I just build a whole different wrong.
Cool.
Level.
Yeah. So that's like low level, right? And then they have their own type description language that is also about memory layouts. That is on the next level. It's called TLB, like type layout, where they say, okay, we have data types. Like what is a block? What is a message? What is a transaction? What is a currency? All of the things consist of fields, and fields consist of other types. And whatever you describe in this language has to map into those cells. And so you have to lay your data. If it doesn't fit in those bits, you put them in this inner cell. So in this type language, you have a little syntax that
So it's like another level.
Yeah.
The cells.
Yeah, and then you will cool. And then there's this giant file of data structures in TLB that is compiled to C++, and all your tools and frameworks have to work with those data types.
Yeah, actually, like it's the first time right now that I've heard this kind of description of TLB. I thought I couldn't understand why we have TLB. I thought it's just for optimization in case I want to optimize, and it helps for optimization later on, right?
Optimization of what? What do you mean?
So, for example, I have a contract, and I would want to describe with TLB the structure of incoming message. I don't have to do that, right? Like it will work without that. Why would I have to create it?
Well,
I've seen contracts without TLB schemas, like without maintained TLB schema.
Well, TLB is really for the people, because in your contract you really only work with cells and bits, right? So you have to look like if you take the fancy language, it says okay, here's the tools to work with cells and bits. So you can read any number of bits you want, and you can build cells and unpack cells, and that's all you got. And then you will have to use this TLB schema on the side to understand how many bits to read and how to name the variable where it goes. Right, so this is a sort of like a deficiency of fancy that doesn't let you to express TLB schemas directly in the language. You have to do this manually.
From one side.
Yeah.
So because it's actually outside file.
Yeah. So you just describe the TLB schema in one place, and then you just manually read those bits and fancy. So that's not so fun. So that's why,
Not at all. Yeah. I feel like I like how they do it. Like after every layer, they do this like thin layer.
Yeah, it's like a blockchain.
This thin layer is like you see.
All right.
I think we're missing this one. Oh, shit. Okay, so all right, we're done, like we went through cells. We had a little chit chat about dicts. Dictionaries.
Dicts.
Dicts. Yeah. No, not what you said. Yeah. So, and I've heard your point on another conversation that, like, it's not a. Is it like an anti-pattern to use dicts inside like big dictionaries? Because you were talking a lot about try to not store a lot of data that is user related on the main contract, and like what are some, let's say, things that we have but we should not use? Let's put it that way. Like dictionaries, for example. Is there many cases where we're going to use them?
Well, let me unpack this a little bit. In Ton, you are given a flexible programming model where you can have lists of things. You can pack them cleverly in the cells, and Ton comes with standard tools to make it usable. So you can, like, on the surface, you cannot allocate the contiguous amount of data because you have to put things into cells, but you have this implementation of so-called hash maps that are actually prefix trees under the hood, but you don't have to think about it. You just have the interface that is like the key value store. Yeah. So everything would work, but you have to be careful because one thing about scalability of Ton is that it is not giving you magic scaling everywhere whatever you do. The only guarantee that Ton gives you is that it can scale out horizontally individual accounts. So if you have 1 billion users with 1 billion accounts, the Ton will make it so that each account may work in its own shard chain in principle. And so when two different users communicate with each other and send money to each other, this communication will not affect the performance of any other users in the network. And that's really the only guarantee about the scalability. If you have an account, if you have a smart contract in Ton that has a lot of data and happens to have a lot of transactions, then too bad. This does not scale out of the box because you are down into this contract. So if you're building a complex system where you have many users using your smart contract application, then you have to be clever. You have to sort of split out the state of your contract and spread it out on the blockchain. And so if you use this dictionary and hash map inside your contract, that can grow, infinitely to the number of users, like 2 million records. And this is no good. I mean, you can do that, but then every interaction with this contract will be hugely expensive. You will pay high rent for storing all this data, and then all the messages that will go through this contract will, create a higher pressure on the nodes that participate in verifying this shard chain. You shouldn't use the hash maps for such use cases. Instead, you should kind of tokenize your data. You should kind of use the blockchain as the array of data, right? Because the blockchain itself scales, right? And then, for instance, if you have user accounts or something like that, then you could say, okay, I will create a contract for each user, and they will share the same code and have some clever communication between each other. And this is how tokens are implemented. And then every user will worry about their own piece of my smart contract because they will have this, individual smart contract. And then when those smart contracts talk to each other, they will not affect, all the rest. And such system would scale. But you have to do extra work. And so if you go to Ton and try to make an application, you have to really, kind of get it and implement it in this unusual way, right?
Yeah, but I'm kind of like, I know how like JTONs work this way. So it's like this was one of the easiest concepts to understand. Again, I've heard it from you in Prague, in this hackathon in Prague, you were explaining this in depth, and this was the first very, very deep, good explanation that I understood in Ton. The thing that you cannot store everything in one contract. It's not a database. You cannot use the contract as a table of data. It's like a set of contracts. But I recently met a case where it was very hard to understand how it could be applied there. So, for example, when you do something like lending, and you would have to calculate, so your contract would have to be able to calculate certain values like price of lending or whatever, based on the contract would have to know a lot of information about all the holders, all the participants, all the people who did previously. And it looks like it brings into the anti-pattern that you will end up storing a lot of things in one place. Just curious if you met some other things where, for example, you knew how it's right, like you knew you have to like write scalable contract, but it's just limitation of Ton that we cannot do it other way.
Well, I haven't seen such a situation yet where it kind of depends on how you put your statement. Like if you put the put the problem in a way that, hey, I need to store all the data in one place, then yes, you have to store all the data in one place. There's no way out of there.
Then God can mercy on yourself.
So you have to actually zoom out and say, okay, what actually is the problem that I'm trying to solve? So for instance, one example that is kind of like tough on the blockchain in general is the order book, right? So the reason the Uniswap exists is to avoid having the order book, because look, in Uniswap, every transaction represents a trade. Someone comes in and it does the exchange with the DEX, kind of shifts on this curve, right? X by like Y equals K, and the prices are updated, and then another guy comes in and pushes it the other way. So every transaction is just for the trade. In the classic order book systems, you will have also other transactions that just put and remove the orders. So you may have no trades at all, and then you will have tens or hundreds of operations that just put orders in and out. And so they update the order book dynamically, and this means that you will have much higher load of transactions if you just implement it naively. But let's say it's okay. Maybe it's it's not so tough. But then in the order book, you have to actually eat through the order book when you make the match, right? So someone added the order, it probably overlaps with one or two or three or maybe 100 other orders, and you have to go and match them one by one. And in trading systems, this is done in one single database, where
that's why we stored
that does the matching. Yeah, that does the matching. So if you just say, okay, this is what I'm doing, then you put this in one contract, and this will not scale at all, right? So it's not the deficiency of Ton. It's just the nature of the application that's just not suitable for decentralized consensus systems.
It's the nature of application.
Yeah, it's the nature of application.
Okay.
Like we need someone that does in a single place, does see all the data and does all this matching on behalf of all the users, right? So that's it's just the definition of a problem is very centralized. So if you want something like that, but in a decentralized manner, then you invent something like Uniswap. So that's really all about like how do we achieve the same trading possibility in a different manner.
But I think it's a lot about, and I want to bring you to one important topic. I think one of the most important that's related to the course that we did. So we get people who are getting into Ton. Let's assume they went through the course. So we have some theoretical parts, we have some basic practical parts. So the basic contracts, basic usage of storage, and explaining the basic scalability of like examples that you just described. But could you say in a few words, after your experience in Ton, how the path would look further? So we just described a very complex thing about, let's say, DEX or like Uniswap, but between our course and the building DEX, there is a whole universe sometimes. Like how do they get there? How do they practice? What could be their path? Let's say, should they build their own product, or they should try to join some team, or they should just practice, I don't know, building jetons or whatever?
I mean, you should definitely try to build anything that's, needed to be built, and then you will learn much faster.
Okay, how do I know what's needed in the ecosystem?
Well, I mean, you're not coming here just, to have a good time. I mean, if you want to have a good time, you just, go, just read stuff and look around. But then you have an idea, like, okay, why do I even care about all this blockchain nonsense? Like, why?
Okay, so sort of problem.
Yeah. What is exactly the practical problem I'm trying to solve? Maybe I want to build an application that just uses the cryptocurrency, or maybe I want to make an application that improves the security or something, or you discover some opportunity on the market that you want to fill. So there is something you want to build. So you just go and try to build it, and as you will try to look for how to make it work, and look what others are doing, you will look through the prism of your problem, and you will learn more. And
it's a good idea to ask yourself the question why I'm here, what I want to.
Well, of course, and
how do I want to solve the?
You should figure out some purpose for your.
What was your purpose when you came in? Like, were you, because I've heard a bit about what your thoughts when you just read it, like the white paper. So what kind of purpose did you see when you came?
Well, my the background story is that I was building originally some software and educational materials around Bitcoin, and then
That's what I didn't know.
Yeah, and then kind of moved into figuring out some protocols for the blockchains that go kind of beyond what Bitcoin is about. Bitcoin solves a really narrow problem. It's like how to create digital gold and make it super secure. So it's very simple, very limited in functionality, and solves really like a single problem very well. But then you have all the other things. There is a reason why you have banking, exchanges, like loans, futures, and everything, and all sorts of custom currencies, gift cards, all sorts of digital assets, right? And Bitcoin cannot, within its security model, cannot scale out to just support all of that. So you have two options: either you just continue building all this, the rest of the financial system in a centralized manner, and Bitcoin is just this decentralized cash somewhere in the periphery. Or you figure out how to maybe use slightly different security models to make the financial system more decentralized, more open. And there is a vast field of experimentation. So, Ethereum started because of that. Like Bitcoin model cannot support this. So Ethereum just had to, create their own thing. And I was researching cryptography, smart contracts, zero knowledge proofs, and all these things. And then when it came time to learn about Ton, it was a nice example of a scalable, well thought out platform for experimentation. So this is where you see that, okay, this thing does everything that Ethereum wanted to do, but it figured out how to do it in a scalable manner.
That's actually that's a cool goal, man. Like that's a cool why.
Yeah, and also
experimentation.
Also, you really want this blockchains and cryptocurrencies to be a large scale phenomenon, not the niche one, right? Because the society wins not when it's just a toy for geeks, but when it's a new social contract. When you have new kind of money, new kind of markets. Because if you have a new kind of super secure market just for two people, it doesn't make any difference. But when the economies exist on this market and it has all this liquidity to be actually useful to everyone, that's when you have dramatic change in society. So it's really important to have the scale.
So basically, what Ton offers to people who come, it's like it offers the scale. Actually, not just technologically, but also we give some hopes on Telegram's help on that, and then you just come and you actually I finished this one. I don't know.
Yeah, there's a yellow thing, and the sticker.
Oh,
I guess skip the sticker.
So what I want to say is that you're coming, like anyone who's coming here is sort of like experimentator, because that's what I liked in your example, that when you come to Ton, you finish the course, try to experiment and try to see some things that are done in centralized way, and they would actually need to be scaled in case they go like with decentralized manner with crypto, and you should try to build them actually.
Well, that's exactly right what you're saying.
Yeah, because I was mistakenly thinking that I should try to build something immediately to make money, and this was something that I don't think it's a good motivation to have like some quick immediate money, because in a system like Ton, you would need to build first, like like this example with bucket and stones. So you have to first put the big stones,
Yep.
and then you put the smaller stones, and then you just put even smaller and smaller, then just sand and then water, and still like it's feeling very
Exactly right. Yeah.
in different ways. So if I would advise something from my small experience, and you say if I'm wrong, that guys should actually try to look into infrastructural things. Like, I don't think it's a bad thing if every team, like if there will be 10 dexes, it's okay. Like if they will close, half of them will close. And it's just, we'll invent 10 ways not to do dex on Ton, because no one who is coming from outside, they don't know how to build dex on Ton. They come and like every dex is different. Look at the transaction paths. It's crazy. They're so different. And we're just inventing infinite amount of ways how not to do things on Ton, right?
Yeah, the cool thing about this, kind of cryptic aspects of the platform is kind of complicated, it's weird, it's kind of promising. So people are like, okay, we have something to work with, even though we don't have a clear guidance. And so they start, doing something, and maybe, half the time it's just, wrong, but you don't know until you try. Yeah. And I'm not saying this like I know how you should do things. I'm just exactly like everyone else. I'm like, okay, we can do a lot of different things in different ways, and it's not quite clear what will work and what will not.
Yeah.
And Ton is like, okay, we have all these amazing, crazy tools, and then, just go and have, go nuts. And this is what people actually do. And then after, a few months, you're like, oh, okay, like this actually works, and this is like not scalable or doesn't, fit with the rest of the, standards of community. So we, get some guidelines out of this experience, and then say, oh yeah, now we can, teach people how to do Ton right. And then you receive repeat the cycle.
Yeah, and then you repeat the cycle. Definitely. Yeah, cool, man. Because I think this is something that the newcomers, at some point, I've seen dozens of people who burn out a Ton because
yeah, that's me.
what was the cause of the burnout? Like too many things, or like too many things in uncertain?
Well, for me, first of all, this was the first big, serious startup experience as a founder.
Ton.
In Tonkeeper, Ton apps, yeah. Before that, well, I had, some entrepreneurial experience where, I do one little thing and I kind of control the result.
Mm-hmm.
But here it was, no, there were a lot of things that are, that were new and difficult. So first of all, Ton itself is new and difficult. It's really, with all the experience in, blockchains, still you can come in and say, okay, I get the idea. No, it's just a whole new world. Like, just learn this, learn that, and a lot of new things. Even if you already know a lot about cryptography, know a lot about smart contracts and everything, then suddenly just there's a bunch of new words and jargon and 4 white papers of 200 pages each. It's just way too much. And yeah. So that's one thing. Second thing, you have this, and then you're not just, alone. You actually have to, build a product with the team and coordinate the team. And now, okay, you have to learn this stuff, and then you have to coordinate the team, and this is crazy. And then you have environment in the world that is now, going crazy, right? You have wars, you have sanctions. You just had a preview with this COVID, where all the countries, put the crazy border controls, and then you in this very unstable environment, and you're like, okay, let's have fun as an entrepreneur in this.
Like
exact
learning fun C in this exact time.
yeah. On the other hand, you kind of appreciate why you see why people need kind of personal security in terms of cryptocurrencies. Yeah.
Actually, as far as I understood, you don't have to read all those 500 pages of, like, if you have or you don't have to read this white papers depends on what the level of the problem you're trying to solve. Because if you don't solve very, very deep technical problem, you will not need to figure out too many things about extra currencies and something, whatever. But that's why I truly, when I was building like my chapters of this course, I was thinking a lot about like how to equip guys who can go and try something immediately, go and try something simple, build a dApp with a smart contract as a backend that just manipulates information, like you enable the users to interact something. So that gives them the first hands-on, and maybe just later on they will touch and uncover, meet more people who will ask them questions, and they can actually build something more complex or find an idea that something more complex is missing in the ecosystem.
Okay.
Yeah. So if I would kind of summarize on this idea of from what we talked about from the course. So once you are here and you are actually watching this course, probably you have at least some kind of motivation, even if you cannot like say exact why you're here. You are actually somehow curious about this blockchain. So figure out this why, and then try to learn like not too much, because this will overwhelm you. You should actually learn as much as needed just for the problem identified recently, right?
Exactly right. But then you will often find that, okay, I'm immediately seeing some concepts that I don't fully understand, and
What are you doing?
here, is it this thing? Yeah. Yeah, here's the chair.
On chair.
It's a chair. I don't know if it sticks. There's another
Oh yeah, I'll make it.
drawer. Yeah. So, this is a difficult part, because on one hand, it doesn't make any sense to just go and read all the white papers for nothing. You will load up your brain, fry it, and
You get older faster.
yeah, and it will not give you kind of good working memory of the things that you actually need to work. But then if you start doing the application and you stumble upon cells and hashes, then you really better go past the API in whatever library you're using and go into the white paper and to read a little bit about it to understand what is going on and why. And then you're lucky if the white paper actually is helpful for you, because sometimes you really have to go into the source code to understand exactly how it works. But hopefully the white paper gives you enough rationale to kind of explain why this thing the way it is. And if you're not an implementer of some low-level tech, then you don't have to really dig into the source code to compare exactly what is going on.
Like library documentation would be probably enough.
Yeah. But still, it would be really beneficial for you to just go and read exactly like why those cells are the way they are and how this mapping happens. So,
yeah, man, that's cool. I think this is something that if someone is watching this, something that I would want him to actually feel and hear and take as a takeaways, like encouragement that don't get too. If you don't have a specific problem to solve, don't be too technical. Don't overwhelm yourself with that, and like try to experiment with many things. It's kind of like encouragement, like from mastodons like you who are like long time in Ton and stuff. And I think it would be encouraging to hear something like this from you, for example.
Well, yeah, nothing is impossible. Yeah. Who is this guy?
How was it building this one? I think, yeah. So it's like this, and then
Yeah,
so it had two.
yeah, you put it behind the desk.
Okay.
I think, look, we're probably not gonna finish the whole thing, but I have a cool example what it is. So you come to Ton, and there is the core. There are some main things inside, and then you have a lot of things to build from. So that's exactly what happens to the new guys who come. So I put it right here. Yeah.
Oh, the guy with the photo camera.
I'm getting based to white paper here.
I think there's an offset by 2 dots.
Yeah. So here it would be just
Yeah, the window.
just near the window. Okay.
All right.
Yeah, I think at some point we'll have to let this little house go to sleep.
Yeah, because it's getting too
Yeah.
too
Too detailed and stuff. Yeah. So before we wrap up, what kind of maybe you wanted to say something more to the guys, like who are new. We're talking about guys who are just learning the very basics, and give us some wisdom of the day. I don't know. No.
Well, number one thing I would say is that it's the platform is really clever in a good way. I mean, sometimes you feel like, oh, maybe it's clever, but it's overly complex for no good reason. But actually, it's all this complexity is rationalized. There is a reason for that, for it. And frustrating part is that you don't always understand why things the way they are, and why a simpler solution would just not, do it. And that's frustrating. But I would just say, like, trust me, this thing is complicated, but it's clever. And there are 2 things that obscure the understanding: the temporary lack of good tools and education materials that help answer your questions in 5 minutes instead of 5 hours. That's the one thing. But we're working on it, right? We're trying to solve this. And second is there's just a lot of things at once. So there is some kind of like a steep learning curve. And again, hopefully some education materials will help to break it down into separate pieces, so you can focus at one thing at a time. But to make it all work, all these kind of layers, the cells, the TLB, the TVM work, all this, messages, the architecture of the contracts, all sorts of fees and gas, and how you build higher level entities on top of those smart contracts like tokens and DNS records. All of these things, they kind of very much interconnected. So it just, takes some time to kind of adjust and get used to, but it's worth it. It's really a fantastic platform, and hopefully in a couple of years there will be some better abstractions so that you could get up and running and build something without kind of having to drill through all of this at once. You could just have a better chunked.
I have a lot of questions to you about this abstractions level, and we will touch tact at some point, but it's not today for sure.
I hope so.
Yeah, I really hope on getting to talk about this as well, and about extra currency, of course. They don't let me sleep. Yeah, but anyways, man, we could talk infinitely. It's super interesting to talk with you always, and it's very encouraging.
Well, we did the half the building, right?
Yeah, we at least did half the building. Oh,
yeah. So we have a computer desk. Okay, cool.
Yeah, there is more to build, but you never build it in one day. You actually give it some time, just like Oleg advised.
Yeah. Well, that was a pleasure.
Yeah, man. Thank you very much for this talk. I really think we should talk more. And people wrote me so much after interview with you and Oleg Larionov. So many people actually talked to us like, damn, this is so cool. Like, people are actually talking. This is like, when you hear such information when you read it from white paper, or you hear it from a real person who know what is Lego, like he's smiling, he's laughing, and then this is the whole chunk of encouragement. I really appreciate that, man. and I really hope
Thank
you
you.
can make it more often.
Yeah, let's do the second chapter kind of more, technical. Where,
Yeah.
dive into certain things.
Yeah.
Maybe we'll just kind of just do a live reading of all the white papers.
Yeah, why not? Yeah, let's think about let's meditate about that.
Okay, cool.
Super. And
Yeah.
you guys, thank you for making all the way through this video and watching our Lego, listening our talks about Ton. And I hope you find it useful. So like, subscribe, and I'm gonna see us soon.
Peace.